Hi guys, and welcome to today's webinar session brought to you by Verzeo, India's fastest growing professional training and certification platform. Our session today will be on the topic DevOps Tutorial for Beginners, which focuses on DevOps, which is one of the most important tech principles of modern times. DevOps as a field is in great demand within the industry and requires a diverse set of skills. So let's get a quick glimpse of what we would be learning in today's session. We will be having a brief introduction into DevOps concepts, and we will learn in depth about the DevOps Lifecycle model and also have a look on the up and coming steps post the creation of the same. Our instructor for the day will be Mr. Neeraj Kheria, who is a master of all trades, having trained over 5,000 students and professionals in domains ranging from digital marketing to DevOps, as part of companies like Accenture, Ernst & Young, Mercedes-Benz, and eminent universities like IIM Kozhikode, to name a few. To know more about us and what we offer, you can visit us at our website www.verzeo.in. You can also access the diverse learning content we have on offer by subscribing to our YouTube channel and clicking the bell icon to receive notifications for new uploads. So without further ado, we will now shift the spotlight onto our instructor. Over to you, Neeraj.
So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So before we get started, let me quickly introduce myself to you all first, so you can be aware of the person who is going to be your mentor for next hour. So my name is Neeraj Kheria, and I have been working in this IT industry for more than 12 years now, where I have been leading the global design and development teams for designing enterprise solutions for different industry verticals, including insurance, retail, banking, pharmaceutical, aviation, and location-based services. And mostly I've been active in the markets of India, US, Canada, Singapore, Australia, and other Southeast Asian markets so far. And in terms of the training front, I have been working as a corporate trainer as well since last 5 years, where I have been training the workforce of companies including Accenture, Mercedes, EY, Capgemini, Adobe, Credit Suisse, NIT, Grab, among others, in making sure their workforce is all updated in the current trends and technologies, specifically in cloud computing, in data science, and in big data engineering technologies. So that's a nutshell of what I have been doing for almost 12 years now. So today we have gathered on a discussion on DevOps, on discussing what exactly DevOps is, how it is structured, and where we are going to use DevOps strategies. So the main agenda for today's session is we are going to have a complete introduction on what exactly DevOps is, its entire life cycle, and the next step once we are done with the webinar. So DevOps, as we know, is a complete life cycle. So when we talk about DevOps, DevOps is a complete life cycle. Just like earlier, we used to have multiple software development life cycles. So earlier, if you remember, we had a cycle called as Waterfall Model, where we also had, we use multiple other models like we have for Agile as well, which we use for development of any particular project. Now, when we talk about Waterfall Model, then we had multiple steps in Waterfall. Like we had, first of all, we had the steps for the discussion. That means, again, getting the entire insight from the customers. Then we had the steps for working with the entire team for setting up the entire design. Then we had the steps for setting up the entire development part as well. And then we had multiple other steps that we had to always take care of when we were focusing on the waterfall model. So earlier we used to have design, then we have implementation, then we have testing, deployment, and maintenance as multiple strategies as a part of waterfall model. Now, the main drawback with waterfall was that waterfall was successful, but it was successful only for small scale projects. That means if we have a big requirement, for example, let's say we are developing a complicated applications. Let's say we are developing a complex application. Then in those complex applications, the waterfall model simply failed because the waterfall had one main drawback. So if we wanted to go back to any of the previous state in waterfall, then we have to simply wait till the entire process was completed. That means unless we have the entire process executed, we can't go back, right? That means suppose after design phase, there is something that we need to change in the design phase. then here we have to wait till the end, and then only we can have a clarity on what exactly is the bug. And that means by the time bug has been reported back to the developers, it has already been a week, 2 weeks, or 3 weeks, right? That means if we fix a bug after that long, then obviously we are going to suffer a huge loss in the user base for our application, and that means we are simply going to be out of the market. And definitely, now that is simply a horrible situation for any business that we can think of. And that's why we have to make sure we are using a well-planned strategy to make sure we don't have any kind of hindrances. And again, whenever we want to roll back to any of the changes, we are able to do that, and that too at a continuous manner. And that exactly is what DevOps offer us. So if we take a look at the component of waterfall model, then we can see, first of all, we had requirement gathering analysis, then we had to move to design, then we had to move to implementation, testing, deployment, and maintenance. And each and every of these steps were focused on a given timeline. And if we want to go back from implementation and testing, and now once we have tested the application, now we want to send the report back to the developers, then we could not do that because we had a fixed timeline for each and every step, right? Now, this was also solved by another method, that was Agile. So Agile simply solved the issue of designing, implementation, and the testing phase. For example, if we had a requirement of testing any of the components, then we can easily do that. And the main issue faced by these and by Agile, so Agile solved the issue of iteration of design, implementation, and testing, but it simply retained the sequential steps for gathering the requirement analysis and for deployment and maintenance. That means for getting the feedback from the real world deployments in terms of the production servers, then also it has to be a complete sequential step. And that's when came the process for DevOps. So DevOps has basically 8 different phases, starting from planning, coding, building, testing, integration, deployment, operation, and then we have monitoring phase available. So we have multiple phases available for each and every component here: designing, planning, coding, building, testing, and multiple other phases available as a part of DevOps. So now when we talk about the different phases here, let's start with the planning. Whenever we have got any application requirement, or we can say when we get any particular project, first of all, we have to plan out how exactly that project has to be executed, among which different steps how we have to execute that one by one. Correct? And that's why we have tools like we have Trello, which we can use mostly for the planning purposes. Let me annotate that so that it can be clear for everyone. So first of all, in planning phase here, we can use any tools like we have Trello, where we can use tools like we have Trello for the planning purposes. And then once we are done planning with each and every stakeholders and our team members, then we can move ahead to the phase of coding phase. So coding is basically a collaborative work. Suppose if we have multiple team members. Now, when we talk about coding phase, if we have multiple team members with us, now let's understand then we have to have a centralized repository, a centralized system of getting the code by different developers if they all are working on the same project, and then making sure the entire versions of each and every changes being done by these individuals are also maintained. So let's open up the notepad to have a complete clarity of how this is structured, so that we can have a quick understanding of the coding phase as well. So let's say when we are working with a global team, let's move to the annotation. So if we have a global team, let's suppose if we have a global team of developers, one team is sitting in Seattle, the other team is sitting in Johannesburg, the other team is sitting in Tokyo, and we have other teams sitting in Sydney. So let's say we have a global team which is working on a single project, and each and every team members, they are working on different components. For example, let's say we have a team for Seattle. Seattle team is working on the header section for the, or we can say for the dashboard. Johannesburg team is working on the entire data component of the same project. Sydney team is working on implementation of the ad tech system on the same platform. And the team for Tokyo is working on the front end, that means working on the entire we can say the front end and also on the back end for the entire application itself. And they all have different work divided, and then that means if we have a project manager whose sole responsibility is to make sure it fetches the code from each and every team members, what they are working on, and to maintain a copy of each and every changes being submitted by these team members. For example, there has been 10 different changes from Tokyo and 15 changes from Sydney, 20 changes from Johannesburg team, and again 10 changes from Seattle team on a daily basis. So if we have multiple team members working on the same project, then we have to have a centralized system, because if the project manager does not have a centralized place to store the code being submitted by each and every developers, if the manager does not have any kind of version control system to keep a track of all the changes happening, then that will create a good problem for the project manager and also for the entire project as well, correct? And that's why we need to have a source code management. So we have source code management tools. Like we have the most popular, the one that we have is Git. Now, Git is basically used for maintaining multiple versions. Git is basically used for maintaining. In source code management, we have a centralized repository, like we have GitHub. The most popular one is GitHub. So I'm sure you all must be familiar with the concept of GitHub itself, where GitHub is the most popular source code repository. And then GitHub also when to maintain the versions of each and every changes happening on the website or for any application code, we use a tool called as VCS. We have version control system. So first of all, when we say version control system, let's understand what exactly we mean by versions. Let's say we are working on any website. Let's say this is a first copy that we have given to our client. And in this copy, we had something called, I suppose in this particular version, we had, let's say we have H1 element, then we have H2, and then we have added a simple paragraph. This was the first copy that we had given to the client. And after a while, the client came back to us and the client asked for changes. So we did the change, and now the client wants, first of all, the H2 tag, and then the client wants a paragraph, and then followed by a simple division. And kindly excuse for the beautiful calligraphy that we have. That's what happens when you try to write using the pointers. So suppose this was a second copy, and there has been n number of changes being asked by the client here. There can be n number of changes. Now, let's say after 20 changes, now the client came back to us. Now the client wants to restore the fifth copy that we had given to the client. Now, suppose if we're not saving that fifth copy, then obviously we are going to have really hard time in giving that fifth copy change, because first of all, we won't even remember what we had done in fifth time. And even if we remember what we have done, what we have given in the fifth time, we again have to sit down and rewrite the code every now and then. And if the changes, the client keeps on changing, the request, obviously we have to redo the same thing again and again. And that means our work is not going to end anytime soon, correct? And that's why, to make sure that we don't have this kind of situation, we can take the help of versioning. We can take the help of something called as versioning. So using versioning, we can so each and every change that we are doing in the code, we can save it as a version. That means we can save it as version 1, version 2, and till n number of changes that we are doing on the same project. So that whenever we need to switch to any particular change, we can simply roll back, or we can simply shift to that particular version. And that exactly is a critical component when we are working for any solution, whether we are talking about a small scale, medium, or large scale deployments. So first of all, are we all clear on the concept of versioning till this point? Please give me a quick information, everyone. You can all use the questions tab to give me a quick information, guys. So drawing is highly appreciated, but again, we will appreciate more if the confirmation can come via the chat window. Thank you so much. Guys, I would really appreciate if you all can please leave the canvas for me, and you can use the chat window that you all have the access to. Thank you so much. All right, so, and we have two different components for version control system. We have two components for version control system. In VCS, we have two different types available. We have distributed and then we have centralized. We have distributed and centralized. Now, first of all, let's discuss on what exactly we mean by centralized version control system. Let's say we have multiple developers. We have developer 1, 2, 3. And they all are working from their own station, as in their own workstation itself. And they all are working on a project. And once they are done with their own project, obviously they want a centralized system, or you can say centralized repository to store their code, correct? And that's why, guys, again, we would really appreciate if you can leave the canvas for me, because in doing that, we are not even just creating confusion for us, but also for others. If you can do that, I would really appreciate that. Thank you so much. So suppose we have 3 workstations with us. We have workstation 1, 2, and 3. And then we have a centralized repository. Like for example, we have a centralized repository. Now we have the first workstation once the first developer is done uploading their code, then once they're done working on the code, then they can simply upload their code and store it in a centralized repository itself. All right. And then we can, now for example, after second one is also done, second one can also push the code toward this centralized repository, or we can refer this as remote repository as well. Remote repository. Same way for third one. If third one is done, then we can upload the code from third one to the centralized repository. That means a project manager can have the access to the code being pushed by every developers, and in that too in a centralized location itself. And this is not a local copy. This is basically a remote repository. That means every developer will be having the access to this remote repository. So whenever they are done with working, for example, let's say when they're working on any bug fixes, or they're designing the portion of a project, then they can simply push their code and make that code available in the centralized repository. All right. And then we have the component of, now this is what we have, centralized version control system. When we have a centralized repository, that is a remote repository which is made available to different systems out there, so that once they are done, they can push the code directly to the centralized repository itself. And this is termed as centralized version control system. And then we have another component available, another type, that is distributed version control system. So in distributed version control system, what we have something called as a local repository. So the setup remains same. If we have multiple developers, they will continue to push the code, but here we have something called as local repository, which is available as a local storage for each and every system out there. So once they are done working on any code, for example, let's say in the complete day, they are done, they have been making multiple changes. So all the changes are going to be saved in the local repository. And whenever they are done making the changes, then they can simply push the code from local to the centralized repository, right? They can simply push the code to the centralized repository. So that means for any reason, if central repository is not available for any reason, still the users, they can access the code which has been pushed from the first developer, we can say from any developers out there. That means they don't have to wait for the centralized repository to be up and running. So they can simply save the code in the local repository, and then they can push the entire code at once in the centralized repository, so that they can maintain a much cleaner code, and the code can be much more, let us say, readily available by every developer out there. And SVN is also one of the vendors. So SVN is an example for centralized version control, whereas Git is an example for distributed version control. And then we have the build phase. So using build phase, now once the code has been made available, obviously we have to create a build out of it. When we say creating a build out of it, we simply mean, let's say we have a code for Java. Java application code has been deployed on the same coding phase. Then for using that code, obviously we have to create a build out of it. And for building purpose, we have tools like we have Mavens, Apache Ant, and Gradle. So these are the most popular tools which are used for building the code. And now when we say building a code, then we simply mean that building a code simply makes sure that we are taking care of the compilation, code review, running the unit test. That means to validate the entire code structure is completely functional without having any kind of issues. And once the entire build has been created, then we have the next phase is test phase. So test phase is basically like a testing tool available through which we can define multiple scripts and we can let those scripts complete the test for us. Let's say we are developing any web-based application. And now we want to test out if that component, for example, if that particular web page is each and every component in that web page is working or not. Then we can use tools like we have Selenium, JUnit. So these are one of the most popular testing tools available in DevOps, so that we can use these tools to check if the components are working as they should or not. So that the same test report can be sent back to developers to allow them to make the changes in case there has been any bugs. Then we have at the core, we have integration. So integration is basically, now this is also called as continuous. Now each and every phase, these are continuous. That means the main core of DevOps is to make sure every process has been made continuous. That means there's minimum human involvement in the entire process, so that we can let the code being pushed in the GitHub repository, and once the code is available, we can create an automatic build out of it. We can create multiple tests. We can create multiple testing scripts and make it available, so that as soon as the build is created, those testing script can be attached to that build, and then they can be pushed to any deployment servers that we have. And for integration, we have tools like we have Hudson, Bamboo, Jenkins, where Jenkins is the most popular tool available for continuous integration. So when we say integration, here we can define the entire pipeline. Let's say when we take pipeline. Now in DevOps, we can define the entire pipeline. When we say pipeline, we simply mean pipeline is a set of sequential steps that we have to take care of. For example, in the first step, we can define we are going to go for the source code tool. Or for example, let's say we have a source code management tool. Now, we want that as soon as a code is available in any of the source code management sources, for example, we are using GitHub. So if for developers, they are continuously pushing the code in source code management. So for example, we have developers A, B, and C, and a new code has been pushed from A. So as soon as a new code is available in the source code management, we want that a build out of it should be created using any tool that we have defined, using Maven, Gradle, Apache Ant, any tool. And then if we already have a testing script defined, then that particular testing script should also be attached to that particular build that has been created, correct? And then we want that again, based on if you want to run multiple tests here, or if you want to deploy them on production staging environment, then we can automatically send that code to the servers as well. So that each and every step can be fully automated. So we don't have to manually create a build. We don't have to manually attach a testing script and then deploy on the server. We can let these processes be executed in a given sequence, and this exactly is called as a pipeline. This is actually called as a pipeline that we can create on top of continuous integration tools, and that's why we have tools like we have Jenkins. All right. Then we have tools like we have now. Then we have tools for deployment, like we have Docker, Vagrant. So when we say deployment, we simply deploy the entire solution on top of containers. So we have multiple containerization tools available, like we have Docker, we have Docker being the most popular containerization tools available. For example, let's say when we're deploying any application there. So again, we can create a complete VM as in a virtual image, but VM contains the entire operating system host files. It then contains the entire application files and then the data. So again, that means the entire VM becomes really heavy, ranging from, let's suppose, it can be 500 MB, it can be 1 GB till it can be 1 GB plus size as well. So that means this becomes not feasible to be shared among multiple developers team. And that's why we can use the concept of containers. So containers, they simply package the application and they package all the libraries and bins that is required for running that application itself, so that we can make the entire container self, we can say, autonomous, where all the dependencies are already inside the container itself. And then we can deploy the containers, we can share the containers for the deployment purposes. And for creating these containers, we have tools like we have Docker, and we can, if we want to deploy the entire application in a cluster of Docker containers, we can easily do that as well. The Docker is the most popular tool for containerization. Now, after deployment, we have the operation phase. So operation phase includes the tools like we have Chef, Puppet, Ansible, SaltStack. So these are basically like a monitoring, not monitoring, but configuration management tools available in DevOps Lifecycle. So when we say configuration management tool, let's understand what exactly we mean by that. Let's say we are running a server. We are running a server, and here we want to make a definite change in terms of PHP. Here we want to have a specific version of PHP or specific version of MySQL. Here we want to deploy one particular application code that we have created. Or if we had deployed any application code, now we want to roll back. Then these type of changes we can do easily for a server count of less than 10. If the server count is less than 10, then we can easily open up any number of servers, any server, and we can do that one by one manually. We can do that. But if we have more than 10 servers, let's say if we have 1,000 servers available, then doing the manual configuration for these 1,000 servers is practically not possible. And let's say somehow we even managed to do that, those 1,000 configurations. Then after, let's say after we have updated PHP, we found out that this new version of PHP is hampering the quality of our existing application. That means again we have to reconfigure those 1,000 servers that we have configured just now. And again, this is like a nightmare for any particular operations team, correct? And that's why, to avoid this kind of situation, we can take the help of tools like we have configuration management systems. So using configuration management tools, what we can do, we can create a complete template where we can define what all configurations we need to change on the servers. And then we can use this template to configure these 1,000 servers automatically. That means if traditionally, if we require, let's say 10 days to configure these 1,000 servers, then using the template and a tool for configuration management, we can do that within an hour itself, whether we can say within minutes. That's what exactly configuration management system is all about. And we have multiple tools for configuration management, like we have Chef, Puppet, Ansible. They all have the same principle, but different structures and different use cases. And that is something that we are going to discuss step by step as we continue towards our certification. And at last, we have tools for monitoring. And for monitoring, we are going to use tools like we have Nagios, Splunk, and so Nagios is the most popular tool for continuous monitoring. When we say monitoring, that means obviously we have to keep a check on all the servers that we have up and running. Because if we don't keep a check on the performance and the health status for the servers, then we are not going to maintain the fault tolerance for the entire architecture. And this is something that we have to take care of in real-time use cases. And that's why the most popular tool out there is Nagios, because it also has a complete dashboard that we can take the help of. We also have multiple other tools available as well, like we have Prometheus, where we can use Prometheus, we can use Grafana, we can use Splunk. There are multiple tools, but the most popular one out there is Nagios. And in DevOps, for each and every phase, there are hundreds of tools available, guys, but it does not mean that we have to be well aware of every tool available in every phases. Even if we know just one tool from every phase, that means in planning, we can have the knowledge of, let's suppose, Australia. Then for coding, we can have the knowledge of just Git. If in building, we know only Maven. In testing, we know only Selenium. In integration, if you know only Jenkins. In deployment, we know Docker, Chef or Puppet or Ansible, and then we know in monitoring we can know about Nagios. Then we are good to be called as a really good, not just good DevOps engineer, but a really good DevOps engineer. Obviously, having knowledge of multiple tools is always add-on, because we are more open to do the custom changes for the clients, because we may never know which particular platform they might be running on. All right. So I hope each and every phase, the overview for each and every phase is clear for everyone. Please give me a quick information, guys. I hope the overview for each and every phase is clear for everyone. So thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.